Hello, welcome to Lab 9, the theory section. This isn't really the lab. This is my house. So for those of you who've been stalking me, why don't you get a good look around? See, this is my office. There's a whole bunch of books I've got over there. See all those books? Yeah, all over there. That's my computer. That's me. That's the outside world. Okay, so now you know what it's like in my house. Based on some of the fingerprints on the outside window, I think some of you have been over here anyway. So we're here to talk about the theory behind Archimedes' principle. Well, what is Archimedes' principle? Let's read it from the internet. It says here, any object wholly or partially immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. Huh. What does that mean? Well, what it means is the force is equal to the weight of the fluid displaced by the object. So how do we figure out what the weight of the fluid, in this case water, is displaced by an object? Well, all we have to do there is we have to multiply the volume of the object, okay, by something to get the weight. Alright, let's think about that for a minute. Okay. The weight of the water displaced. Well, that's going to be equal to the volume of the water displaced times the density of the water displaced. That's the density of water. That gives us the mass of the water displaced, right? But to get the weight, we have to multiply by something else. G. Alright. So, now we know that the weight, the buoyant force, is going to be equal to the weight of the object in the air minus the weight of the object in the water, and it's going to be equal to that force. That's Archimedes' principle right there. Now, if this is a positive number, well, somehow this is going to determine whether it sinks or floats. We'll have to figure that out as we go along. Alright, so how do we get there from here? Well, I don't know. I do. Alright, what we can do is we can also say that the mass of the object is equal to the density times the volume. That's the density of the object, not the density of water. Okay? And we can multiply both of those sides by G. That's the weight of the object in air. Okay, you follow me so far? Just weight of the object in air is equal to mg, which is equal to the density times the volume times g. Okay. Well, let's rearrange these terms just a little bit. Let's take this and say that Vg is equal to the weight of the object in air divided by the density of the object. Okay? You with me so far? Well, this looks sort of familiar. Yeah, it's up here. Because we can also say from this that Vg is equal to the weight of the object in air minus the weight of the object in water divided by the density of water. Hey, you know something? That's a Vg, that's a Vg. Well, we could then say that these two are equal. Yeah. Well, that's pretty cool, isn't it? Because then we could rearrange these terms and take this over here and these two over there and blah, 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 blah. You can do the math yourself if you don't believe me. I'll try to do it in my head as I go along. That the density is going to be equal to the weight in air times the density of water divided by the weight in air minus the weight in water. Now the neat thing about this is all we needed to do is weigh the object in air and weigh the object in water, because we know the density of water and we get the density of our unknown material. Pretty cool, huh? I thought so. Alright, so this is where the formula from the book comes. Y'all got that right now? All of you? Are you sure? Okay, so remember, Archimedes' principle. The weight of the object, let's see again, let me read it again. I can't remember it. Any object wholly or partially immersed in the fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. So, that's all there is to this one. And I'll see you in the physics lab.